So this is basically where we left off, right? We finished this whole rental car company total charge calculation function. And I just walked through one way to do it. Only one. Who can tell me how many ways there are that I could have done it though? Literally. At least 3. Yeah, you're right. There's a lot. So the way I did it is not necessarily good. I think it's fine. In fact, I look at it and I look at this and I go, you know, now that I've got a working version, maybe what I should do is do a little refactoring. That's just a fancy way of saying, just kind of like changing the code a little bit to clean it up, maybe, improve it a little bit. You know, nothing major. But the way I did it, if you were to think, well, I would have done it slightly differently, great. It really doesn't, like, if it works, it works. If it's good code, it's good code. That's awesome. Do not think for a second that, oh, I should have done it that way. No. No. Maybe you even have a better way to do it. I don't know. It's just this is one way to do it. In fact, when I look at this, first thing I see is I've got the function call right here on this line of code. And that means that line of code is doing a lot of work. That line of code, line, what is that, 26 it looks like, is doing a lot of work because it's got a function call. And then based on the result of that function call, it's multiplying that by 0.3 and adding it to 50 times the number of days. That's a lot. It's not crazy amount, but to me that's a lot. And perhaps, I mean, I really don't like my lines of code doing too much work. I like to keep it simple. So maybe what I should do is I break it down by just having the function call and then saving the result as a variable and then throwing it in the calculation. It does the same thing. Functionally, it's the same. But I think this is a little bit improved, if you ask me. Another thing maybe I would do is I would say, you know, I only needed the average calculation if it was rental code classification D. The B one, it didn't matter. So, I mean, up here, I calculated the average number of kilometers, but I only needed the average number of kilometers for the numbers above the average. Oops. Maybe I should have thrown that inside the else, because it really didn't need to be out here. There's nothing wrong with it being out there, but it wasn't needed elsewhere. So maybe this is a better version. If I run it, it's probably not going to work because I didn't run all the cells. Yeah. Let's go runtime. Well, hold on, this one ain't going to work. Hopefully this works. Ah, shoot. Yeah, well, we can stop that one. Run. And yeah, it looks like it worked real good. Now this right here, I know I mentioned this last time, but I'll say it again. This is entirely valid. The reason I did this was, I mean, look. It's starting to get really long. It's going off the screen. So to eliminate that, I could stack them like this just so it's a little tighter, a little cleaner. So if you wanted to do that, feel free. If you hate this, all right, never do it. It doesn't matter. It's just, you can do that. Did we talk about this right here, this special little plus equals? Raise your hand if you have no idea what the hell that means. Yeah, you're normal. So all this is a shorthand, and you're going to see this shorthand a lot. and similar shorthands, such as minus equal. But what this means is this right here, I'm going to write its equivalent line of code on the following line. Those two lines of code are the same. It means it's a shorthand for add to this variable that amount. So if let's say total charge was 10, well that means total charge equals total charge plus 10 times the number of days. So I'm not replacing the variable with the new value. I mean, I am, but I'm using the contents of the variable to help me calculate the new value. Long story short, it's a shorthand for total charge equals the total charge plus 10 times number of days, plus equals. Based on that, here's a quick little quiz. What do you think this would do? Well, it would be, and maybe this is what you were saying, it was just hard to hear. It means total charge equals total charge minus 10 times the number of days. What about this one? Well, this will probably crash. Multiply equals, what do you think? Uh-oh, I stumped you, eh? Well, it's total charge equals total charge times. There is also in other programming languages another shorthand. It wouldn't work here, but let's say I have this. That means if you're like in another programming language like Java, C, C++, C#, that's another type of shorthand. That means just to add one. So it's an even shorter shorthand. Now, I'm not 100% sure if this is true. It might be an apocryphal story. I heard the reason that we have this shorthand dates back to when computers were really terrible and our monitors were really narrow. You can only fit so many characters on a line. And so this saves characters, which is really good. Our files are a little bit smaller. Maybe I'm worried about file size. It saves characters. I can fit the whole expression on one line instead of it getting chopped off. In reality, I suspect it's just programmers wanting to be lazy, because that's what programmers are, lazy. Anyways, you will see this frequently. If you like this, go ahead and use it. If you don't like it and you think it's terrible, don't use it. It doesn't matter. It's fine. Anyone want to, here's this, I'm going to ask you a question, and I think this is a fun one. Why did I start by assigning total charge equals 0? I'm going to give you a moment. Look at this code. This is a tricky one. There's nuance to this, and I'll be curious if anyone actually knows why. If no one knows why, that's fine. But there is a reason.
Like for one of the if statements, you're doing total charge plus equals like 10 times number of days. If it's not already initialized, then you can't exactly do that operation on it.
That's 100% correct. So let's say they drove, I mean, in this particular case, total charge is going to be assigned to either, like, one of those two conditions is going to run, because there's an if and an else. It's going to run. So this should still work without it, right? But if this wasn't here, if total charge wasn't assigned to 0, and then I tried to say total charge equals total charge plus something, it's going to say total charge isn't defined. So I had to start it with some, like, I needed to make it exist with no value. If that made sense to you, good. If it didn't make sense to you, it's not overly important right now. It's a nuance that will become a little clearer probably as we get more and more practice. But it was interesting to see someone kind of see why it was there. Any questions about this topic, the putting it together? I want to be very clear. What I showed you, again, Do not think that this is the definitive way to do it. No. Even I would even look at this and be like, yeah, I should probably clean it up quite a bit. It's just one way to do it. It's fine, it's good, it'll work. Arguably, there's probably better ways to do it. There's probably worse ways to do it. If you would have done it slightly differently and it would work, and you'd say, I think it's still good code, then it's probably fine. This is just one way to do it. There are so many ways to go about solving this problem. And this is, like, look, obviously this is like the most complex problem we've looked at so far. Or maybe you would say the assignment is fine. But it's still not crazy complex. It is the most complex we've kind of talked about in lecture, but it's not crazy. And even with just this little bit level of complexity, we could see all the variety of ways this could have been coded, and it would work just fine. Any questions? Something else, one of the things I would have said was maybe, you know what I could have done? Maybe I should have age as a constant, right? Maybe I should have set that as a constant, because if I'm a programmer and I come along and I say age less than 25, they had $10 a day, you know, okay, I could probably figure it out saying like, okay, yeah, they want to screw young people, I get it. But like 25, is there a reason for that? Maybe there's a special thing, maybe, like why 25? Maybe I have a constant in my code somewhere. Oops. Oop. I don't know, Now, when I come along and I see the constant, I hate young people charge age, it's a little bit more descriptive. Oh, this rental company just wants to, this is terrible, right? I get it. But a constant could arguably make this more descriptive. Maybe you wouldn't have thought to do a constant, maybe you would have. It doesn't really matter. All right. No questions? You're all good? All right. So, what's next here? If the web page will load. Okay, loops. Now, I will say, first and foremost, if you're thinking to yourself, we're only learning about loops now and the assignment has a loop in it. Well, I know. The assignment is designed in such a way that you can do it without having formally learned about loops. The goal is to have you just kind of like play with it and figure it out. That was by design. Now, if we talk about loops, maybe it'll help you even that much more on the assignment, great. But I believe in you, you probably could have figured it out on the assignment if you tinkered enough. Raise your hand if you did that part of the assignment already. See, look at that, right? Experts, pros, you can figure this stuff out. That's how to get good at programming. If you ever think, like every year, and I know I said this at the beginning of the semester, I say it, and what I'm about to say shouldn't shock you. If it does shock you, a lot of people have misled you along the way, and somehow I'm the only prof you've had, or teacher from high school you've had, that's being honest with you and giving you good advice. If what I'm about to say to you shocks you, you have been misled. I don't teach you shit. I talk at you at lecture, I provide material for you, I tell you to read the textbook, I give you exercises, I give you labs, I record my lectures, I post everything publicly available on the website. That's all I can ever do. I can't actually make you learn anything. The only person that can make you learn something is yourself. And that's not supposed to be demeaning. No. If that feels that way to you, that's not what I'm saying. What I'm saying is, like it or not, you all have a brain and you are very capable of figuring this stuff out. To be a programmer is to be able to go, shit, I got to figure this out. That's what this is. If you have a prof that's not communicating this with you, Be scared of them because they're not setting you up for success. They are setting you up for failure. They can try to teach you anything, but you have to teach yourself. You're the only one that can make yourself learn something. So, practice. Do it. Try. Throw the question into Google. Do whatever you got to do to figure it out. That's programming. That's learning any new skill. So don't be afraid whenever you see something you've never encountered before. That just means, okay, just got to go figure it out. That's what programmers do every day. Okay, loops. Loops are a great way of having a block of code, like that chunk of code that you have indented. Wait, what did I say, loops? I mean if-else. If-else is a great way to have a chunk of code run. That chunk of code is the indented code under the if or the else, or the if-else, right? Or elifs, whatever. Having it run once. But we might want a chunk of code to run multiple times while some condition is true. So it's not just if the condition is true, it's while some condition is true, run this block of code. So it's kind of like a more fancy if. So first and foremost, I want to make sure that this code right here makes sense to everybody. Look at this code and tell me, and here's what I'm going to do. I'm going to give you 40 seconds to look at this code, and you're going to mentally lock into your head. You're not going to say anything. You're going to lock into your head, what are the 4 values you're going to see printed out? Okay? Take the 40 seconds to figure this out. All right, let's go through this one at a time. Who here thought, well, the first thing I'm going to see printed out is 5? Raise your hand. Good. The next thing I'm going to see printed out is 5. If you thought it was 6, you just misread the code. It was printing out A again. I tried to trick you. Then, who here thought, well, then the next thing to be printed out, the third thing, will be 11. Right? Why? Well, because, well, A is 5, B is 6, 5 plus 6 is 11, and where did I put it? A. Print out A, we see 11. And then finally I say, okay, no, A is 3 now. And then A equals A plus 1. Well, A is 3. 3 plus 1 is 4. I print out A, 4. Raise your hand if you got everything right. Raise your hand if you got one wrong. Uh-oh. What did you do wrong?
Oh, I misread it.
You misread the second one? Yeah, I tried. I got you. Anybody else? I want to know where we went wrong. Okay, if no one else made a mistake, great, good. You're in great shape. Point is, we can reuse variables as many times as we want. I could keep throwing something in that variable. It doesn't really matter to me. All right. A very common pattern, like I already showed you, is something like this. A equals A plus 1. Or A equals A plus some other value. So we can do this, which I just talked about a moment ago. A equals A plus 1 is the same thing as A plus equals 1. The plus equals is the shorthand. We're not going to do this activity because I already kind of broke it for you. But what would A plus equals 2 do? Does? Whatever. What does it do? It adds 2 to A. What do you think multiply equals 2 is? Multiplies A by 2. I love when the code is fairly self-descriptive and kind of intuitive. So, if we wanted to run code multiple times, the way we've done it is by writing the code multiple times. If I wanted to print the word hello out 100 times, I would need to write 100 print statements that all say hello. Not that big of a deal. I could copy and paste, right? Fine. But that's annoying. It's not going to scale well. What if the next time I run it, I want it to run it 1,000 times? And it's prone to errors. Every time I make like a copy of code, maybe I just mess something up along the way. I might blunder, right? So obviously this isn't great. It'll work, but it's limited in how it can work, and I'm too lazy. I don't want to copy and paste a bunch. Even if I can copy and paste, it's still not, I don't want to deal with it. So this is where the while statements come in. All right? I want to be very clear. People, when they learn about while, kind of lose track that really it's just like an if. While some condition that's going to give me a Boolean, if the Boolean evaluates to true, then it runs. If it doesn't run. If it evaluates to false, it doesn't run. So the fact that here I'm using like a counter, don't think, oh, the while loop needs a counter. No. The while loop just needs some arbitrary condition. Well, some condition is true. That's all that matters. While the light is red, do something. Right? That's a condition. While the counter is less than 10, do something. I run this, what do we see? 0 through 9. Why? Well, what does the code say? Counter equals 0. All right, you got to work with me here. What value does counter have? 0. Great. So while counter is less than 10, is counter less than 10? Is 0 less than 10? True. Oh, okay, so what do? We print out counter. What was counter? 0. We see the 0. And then I add 1 to counter. So counter is now 1. We're at the bottom of that while. Whenever Python gets to the bottom of a while, unlike the if where it immediately just returns running after, the while goes back to the condition. It loops back to line 2 there, and it says, okay, is counter less than 10? Well, it's 1. Is 1 less than 10? True. Print it out, add 1. It's going to go all the way down to 9. Okay? Now let's say counter's currently 8. Counter's 8. Is 8 less than 10? True. Okay, print out 8, add 1 to counter. So counter's now 9. Is 9 less than 10? Okay, print out the counter. Counter's 9, add 1 to it. Counter is now 10. So counter does, the variable called counter does become 10. I go back up to the condition and I say, okay, counter, you're 10. Is 10 less than 10? False. The variable counter in this particular code, after it's done running, has the value 10 in it, but we never printed it out. Okay? This loop ran 10 times, but 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a total of 10. Because we count the 0. The 0 was the first time it ran. And to prove, if I go down to the next block and I say print, we'll see the 10. So that's it. It's basically an if statement, but it just keeps checking the condition, and it'll run until that condition is false. But remember, all that the while cares about is that it has, after everything is said and done in that condition, if it sees it true, it runs. So if I write this, what do you think is going to happen? This isn't a trick question. What does the code say? Let's hit run and see what happens. It's just going to keep going and going and going, because will the Boolean next to the while ever be false? No. True is always true. This is never going to stop until I go, okay, stop it. Or I can do something silly like, well, 1 equals 1. I hit run. It's always going to run because 1 is always equal to 1. Or here's a funny one. What about this? What did this code do? Well, counter is 0. Is 0 less than 10? All right, print out 0. Is 0 less than 10? Print out 0. Is 0 less than 10? Yeah, you see. It'll just keep going. All right. Oh, I kind of I spoiled this activity. What happens if you forget to add 1 to counter? Well, it'll just keep running because counter never changes and 0 is always less than 10, so it's always going to be true, it's always going to run. Here's a good activity. Figure out what this code does. I say by hand. I do recommend if you have paper, pencil, write it down. If you've got like Notepad on your computer, fine, try to figure it out there. You're probably going to have a hard time doing this in your head. Maybe you can. If you can, great. But I'm going to give you a few minutes to try to figure out what is that actually doing. You might want to run it with a couple of values of n. I love that someone left a white cowboy hat in here. You're going to want to make sure you're keeping track of both values of n and result, because they're both changing. Raise your hand if you're like done. Raise your hand if you want like 30 more seconds. Okay. All right, this one was kind of hairy. But again, like I've been saying, there's no trick to this other than what does the code say? Follow the code. If it looks scary to you, slow down. You're working too hard. You're trying to understand things too quickly, at too much at once. Programmers are too stupid. Stop trying to be smart. Take your time. What happens? One line at a time. Now this is an interesting example because it has two variables that are changing, the n and the result. And I will say, by the way, that the function that this function is doing, if I were to write a function to do it, I would have done it completely different, but this is designed to be somewhat hard to decipher. And another thing interesting here is this loop's counting down. You start with n, and it asks, well, n is greater than 1, do something. And then n gets smaller every time. So I've got an example here. If I were to call trace through me by hand with the value 4, well, the first time, result is 1. 4 is greater than 1, so result equals results times n. So result was 1, so 1 times 4 is 4, so result changes from 1 to 4. And then n decreases by 1, so n is now 3. 3 is greater than 1, so, well, result equals result times n. n is 3, result is 4, 4 times 3 is 12, so result becomes 12, decrease n becomes 2. So 2 is greater than 1, result is 12, n is 2, 12 times 2 is 24, that's result, n minus 1, so n is 1. When n is 1, n is not bigger than 1, because it's 1, so that condition is false, it stops. We resume running after the while loop, and I return the result is 24. Does anyone know what functionality that did? Factorial. Raise your hand if you've heard that word before. Raise your hand if you've never heard that word before. Did I talk about it in this class once, maybe? Maybe not. All right. Factorial is a fancy way to say, if I ask you what 5 factorial is, that means 5 times 4 times 3 times 2 times 1. The times 1 is kind of silly, but it's there. If I ask you what 10 factorial is, it's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. It's the series of numbers that are like decreasing, but you multiply them all by 1. So that's what this was doing. It did 4 times 3 times 2, and it stopped at 1 because it didn't really need to bother multiplying something by 1. But it was doing factorial. Factorial is a neat operation. And what's neat about factorial is, like if I ask you what 4 factorial is, the answer is 24, right? Because 4 times 3 is 12, times 2 is 24, times 1 is 24, right? So 4 factorial is 4 times 3 times 2 times 1, right? If I ask you what 5 factorial is, well, that's 5 times 4 times 3 times 2 times 1. But we already know what 4 factorial was. 4 times 3 times 2 times 1 is 24. So 5 factorial is actually just 5 times 4 factorial. Isn't that kind of neat? I'll write it out just because I think it's neat. I'll turn on the light here too so you can see a little better. So if I ask you what 4 factorial is, and the way you write that usually is with an exclamation point. So 4 factorial equals 4 times 3 times 2 times 1, right? And if I want to know what 5 factorial is, well, that's equal to 5 times 4 times 3 times 2 times 1. But this part here, right, is actually, I can just kind of go like, forget that. That's 5 times, really that's a 5 times 4 factorial, right? Isn't that kind of cool? So what's 5 times 24? 120, yeah. Because I didn't need to do 5 times 4 times 3 times 2 times 1. I already knew what 4 factorial was. It was 24. I just need to multiply that by 5. 120. If I want to know what 6 factorial is, I just need to multiply 5 factorial by 6. So what's 120 times 6? Is it 720? I believe you. All right. Cool. It's 720, right? Isn't that kind of cool? If I know what 4 factorial is, I can find out what 5 factorial is pretty easily. Right? That's pretty cool. I think that's neat. And here's a bit of a spoiler. This is going to come up again a little later. In a much more fun way, though. Trust me, you're going to love it. And if you don't, there's something wrong with you. Because it's fascinating. Anyways, any questions about this example here? So now I've got another activity for you. I want you to write a function called int sum. It's going to take a single integer n and return the sum of all the numbers between 0 and n inclusively, meaning also include n, right? So if I tell you 5, I want it to be 0, okay, 0 plus 1 plus 2 plus 3 plus 4 plus 5, okay? When you finish writing the function, don't run it right away. Trace through your program and make sure it seems correct. I'm going to give you a few minutes to do this one, because this is a good one. I like this one. By the way, for anyone who's been watching these older YouTube videos, raise your hand if any of you have been watching these older YouTube videos for like the one-offs. Literally no, one person. All right, I'm talking to you then. See how the print doesn't have parentheses around it? That's a Python 2 thing. So if you're looking at it going like, what the hell? That's like the only difference you're really going to need to worry about. Like, okay, that's Python 2. It was a different version, an older version of Python. So the only difference here would be add the parentheses. All right, I better hide that though because it's showing you the answer. Bless you. Did anyone do it differently than how I did it? Did you do it counting backwards?
I may or may not have used something we have calculated.
Oh, you're cheating. So here's how I did it. And this right here, over the past, since I've been doing this, this is a point where students need to have a bit of an aha moment. The code you write is the code you need to do what you need to do. Because some people will look at this and be like, well, how was I supposed to know I need like a separate counter and then like a running total type thing? You weren't supposed to know to do that. What you were supposed to know to do is, I need a variable that's going to keep track of the running sum. And I'm going to need to have a variable that's going to count up to n. So I'm going to make those. The point is, you need a variable to do something, you make it. You make the code do what it needs to do. If I didn't tell you you're going to need these extra variables, but you need them, make them. You got to make sure, like, remember, you are God in your programming world. You make the function do what it's got to do however the hell you want, even if you need to cheat like he did. Now, I could have done this by counting backwards and eliminated a variable. I don't think I'd need the counter if I were to do this. I could probably go, well, maybe I can say like, well, n is greater than or equal to 0. I can make it n, and then n minus equals 1. That'll probably work as well. Yeah, there we go. So I did it counting backwards. So here I did 5 plus 4 plus 3 plus 2 plus 1 plus 0. But where I did it this way, it gets an n. Running sum starts at 0 because that's the running total. Counter starts at 0 because I'm going to want a counter to keep track of how many times I ran the loop. If the counter is less than or equal to n, add to the running sum whatever value the counter is, because it's going to be 0 the first time. Counter, increment counter, repeat, repeat, repeat until we get to the end. And there we go. Are there any questions about this? Now, I'm surprised there's no questions, because this, I would say, is probably one of the first jumps, I'd say, kind of in. You got to make sure you're able to do this like mental jump, leap to where we're operating now. Yeah?
Does it necessarily matter if you add up or subtract?
It doesn't matter. It really doesn't. Whatever you're more comfortable with. My decision on what I would do is, what would be easier to understand in the code? Not for the computer, but for another programmer to look at this, what would be a little easier? Right? That's my opinion. As for which is better, doesn't really matter. You could say, well, the counting down used one less variable. Isn't that a good thing? doesn't really matter. Now you got to be careful. You might say, okay, look, there's no sense of adding 0, right? That's stupid. Just start at 1, right? But now I'm starting to get kind of funny problems here. Okay, why is that happening? Running total, maybe counter should start at, maybe this will work. Yeah, there we go. Okay, so I'm going to start the counter at 1. It's giving me the same result. But who can tell me what the danger of this is? What happens if I give it 0? Well, I got lucky there. I got 1. I guess it can count there. What if I start it there, and the counter can start? I got to try to make this break. Give me a moment here. I'm putting myself on the spot. And of course, I'm not going to be able to figure it out because now there's a time crunch. If running sum starts at 1, counter starts at 1, let's start at 2. Yeah, there we go. If I were to say, well, no, I can reduce the number of time the loop is going to run by just starting the counter at 2 and assuming that look, we're always going to add 1, this might fail my tests. Because this would say the running total up to 0 is 1, and that's no good. It's right for 1, but 0, it ain't right. -1, it ain't right. Huh. I'm going to tell you a quick story. Hopefully I can get it done in time. When I was doing my undergrad, we had a practical midterm, all right? And everything, you know what? I'm not going to have time to tell this story, I don't think. Well, I'm going to try. And I understood everything in the programming course. So I never did programming before. I was a physics major when I started my undergrad. But I like programming. And we started by drawing pictures, programming a little turtle to draw pictures. But then we got to this thing on sound. And I understood the drawing part really easy, but the sound part I couldn't wrap my head around. And so for the test, they told us there's 6 possible questions. They let everyone see the questions beforehand. And the day of the test, so you can practice them all you want. And the day of the test, you're going to roll a 6-sided die twice, and whatever your number is, it's going to determine which questions you're going to do. And I could do the turtle drawing ones easy. I couldn't do the sound ones. I couldn't wrap my head around it. I didn't understand. I finally kind of figured out 2 of the sound ones, but the third one I never figured out. And of course, the day comes. I roll the dice. The turtle one, I could do it. I roll the dice. I get the one sound one I couldn't do. And the job was, you needed to take a sound clip of someone saying rabbit, and you needed to half its frequency. Okay? That's what you had to do. And so during the test, I think we had 1 hour. I got the turtle one working like that. It took me 2 seconds. I was good to go. The sound one, I didn't know what to do. I'm writing, I'm working at the code. I'm throwing everything I could possibly think of at the computer to figure something out. I couldn't figure it out. Meanwhile, everyone else around me is getting theirs working. And of course, no one had headphones, so you could hear people's going like, "Robert, Robert, Robert." Like everyone else is figuring it out, but I couldn't. So I'm sitting there and I'm trying everything, and there's like 5 minutes left, and I'm freaking out. I'm thinking, I'm going to have to drop out of university. I don't understand anything. I'm an idiot. I don't know anything. This is the worst. And then finally, I try one last thing, and I hit run. And what do I hear? I hear, rabbit. And I knew immediately what I had done. I didn't half the frequency. I doubled the frequency. But it was in that moment I understood everything. Everything clicked with the sound, rabbit. I understood everything. And if you go talk to programmers, experienced programmers, 9 out of 10 of them will have a similar click moment. You might be understanding things, and there's a moment where you stop. If you keep at it, you'll have your click. Oh, thank you. Yeah, great story.